We're moving on to a slightly different situation now in simultaneous equations. We start in the usual way. Label the equations. Think about whether subtracting them is the appropriate option. Nothing different so far. So now let's look at this. 3x take away 2x is one single x. Positive 4y take away negative 4y. This often confuses people, but we have this double negative. So that will become a plus. Positive 4y plus 4y makes positive 8y. This subtraction is not doing what it needs to do. The method is called simultaneous equations by elimination, and if we subtract here, we will not be eliminating either of the letters. So subtraction is not the way to go. Let's try and see what happens if we change all of those into pluses. We'll get a positive 5x, and here these will combine to make a negative now. So we've got positive 4y take 4y will make 0y. This is what we want. So having identified that we want to add the equations, we get 5x 0 equals 28. Divide through by 5 and we get x equals 4. And from this point on, everything is much as it was. We substitute x equals 4 into whichever equation we think is easier, probably number 1, which says that 3x plus 4y equals 24. 3 times 4 plus 4y equals 24. 12 add 4y equals 24. Now take 12 from each side. 4y equals 12. Divide through by 4. And we discover that y equals 3. So these two lines apparently intersect at 4, 3, x first, y second. We check this in the other equation, not number 1 this time, but in number 2, which said that 2x minus 4y should equal minus 4. Let's see if it does. 2 times an x value of positive 4, take 4 times a y value of 3, gives me 8 take 12, which is negative 4. It's correct.